The broadcast is now starting. All attendees are in listen-only mode.
Welcome everybody to this September meeting of the BCS SPA Specialist Group. I'm very pleased that two of my colleagues and leading lights of the OWASP open source software development community are with us tonight, Patrick Steger and Gian-Luca Frei. And they're going to talk about the OWASP Application Gateway for us. We are recording this, so I hope nobody has any objection to being recorded if they want to raise a question later on. Patrick will present first, and they're taking questions at the end. But if you want to ask a question, please feel free to type it into the questions dialogue anytime. Just before I hand over, I'll just draw your attention to the fact that in 5 weeks' time, we've got the next of this series of meetings, and this time it'll be with Dr. Stephen Castell, and he can talk about some of the legal implications of software quality. I hope we'll get a good turnout for that, because it's a minefield for many of us, and I'm certainly interested in finding out what I as a practitioner can do to guard against problems of the legal kind. Okay, I'm going to get out of the way now, and Patrick will present, so enjoy the talk.
Thanks a lot, Dino, for the introduction, and a merry welcome to everyone listening. As said by Dino, we are today talking about the OAG, the OWASP Application Gateway. It's a talk of about an hour or so, and we're very keen, obviously, to introduce you to that. And as also mentioned, should you have any questions, please post them in the chat. Most likely we will answer them at the end of the talk, just to keep a clean storyline and keep everything streamlined. But we might also take something up immediately when we see a good fit and when we see the post in time, obviously. So when I talk about I actually mean Gian-Luca Frei, who's a security engineer and security tester with experience in large-scale banking systems and health applications. He's working as Zühlke in Schlieren, Switzerland, and he's actually the founder of this project, OWASP Application Gateway. And the other one here is Paddy Steger, that's myself. I'm also a co-lead of the OWASP Switzerland chapter and working as a principal consultant in security and as a security architect also for Zühlke Engineering in Schlieren. So why do we have this talk? Well, after all, many organizations move to microservice-based architectures, and microservice-based architectures tend to make security a bit harder because you have diverse services that you actually need to secure. And there's still quite little talk about how to secure microservices and make them communicating in a secure way. Then security architecture is for many organizations and teams still an afterthought. So first it's functionality, then it's security, and this often complicates things. And while OpenID Connect is here today as a very strong authentication protocol, that's also much easier than legacy authentication schemes that we used to have, it still requires a lot of consideration to be done right. And last but not least, we often see out in the wild that architectures and applications are very closely coupled to external authentication providers or company-wide application authentication providers, and if they change, there's a huge effort to be done in each microservice or each service to integrate with this new authentication provider. And that's basically the reason why OAG is here. So we're here to help in all these areas. Before starting with a bit more details, let me introduce you to OWASP, the Open Web Application Security Project. It's a non-profit foundation that works to improve the security of software. This is commonly done over a community approach. It means everything we have is for free. You can get documents for free, you can tools get for free, and so on. And you're very welcome to use that stuff. Usually it's quite reasonable and quite good. Most famous projects we actually have at OWASP are the OWASP Top 10, which is the top 10 of the vulnerabilities you see in the applications today, but also kind of tools like an OWASP Choose Shop that is there for awareness and education in the application security area, or also something like the OWASP SAP attack proxy that helps you when doing penetration testing an application, for example. So, and with that, you basically have you survived already the worst, and as you're still here, I'm very lucky to go into more details when it comes to modern microservice architectures and how OAG can help us with that. Let's take a look at such an architecture. Typically, it consists of a browser-based application, often also called desktop application or single-page application, or you name it. And often it has also a mobile application, an app running on either Android or iOS. Then, besides that, we have a bunch of services, microservices, like, for example, a product service or an order service. Or we have a server there that actually is pushing static content, such as the framework for the single page application or static pages without any data in it. And we might also have some other services further downstream that, well, should never be exposed to the internet, are intended for internal use. And all of these players, they actually have kind of different ideas how they want to work and different constraints they need to work with. So, for example, the static front-end server, it doesn't care for the user at all. It just delivers static content to whomever is asking for it usually. Then we have a browser in there. This one is a pretty old player in the game, and his main security storage is based on cookies that can be held secure in browsers. All the other storage options are, well, harder to get right, or more complicated, or not well supported. Besides that, the browser loves it when he doesn't have too many endpoints to talk with. So preferably there are few endpoints for an application or a website to talk with. Then we have the mobile applications. These are basically computers and full-fledged applications with the ability to securely store any data, also over an extended period of time. We also might have mobile microservices such as this order service. That's basically a stateless guy, but he needs to be able to verify the user's identity. So he needs authentication to take place at some point in time. And as I said, we might have things like the reporting service, that it's further downstream, an internal service of that company, and doesn't want to be exposed to the internet, but still requires to be able to know the end user that is actually talking to it. And well, our order service therefore has the challenge to kind of find a secure way to pass identity information from himself to other services, such as the push notification service or the reporting service. And both the reporting service and the push notification service, they want to be able to verify this identity too. They do not just trust the order service, but they want to make sure that the identity they get is the one that was actually agreed with the identity provider, which is the last player and maybe the newest player in the game. That's the guy who usually provides the accounts, the identities, provides also authentication for users, and it wants to play also a role in the game. And now let's add the OWASP Application Gateway to the picture. The idea here is to put it in the middle, in between the web clients, such as the browser or the mobile applications, as well as all the backend services on the other hand, and the identity and access management services or the identity providers, such as an Azure Active Directory, an identity server, or also your company's own authentication service. So we'll have that in the middle, and it's basically there to decouple our services from the authentication mechanism so that changes there are way easier to integrate in the future. It also handles gracefully login for us together with the authentication provider, and it does all the session management for us. Further on, it can give us a head start when we want to realize some trust zone-based security architectures on an enterprise or also on an application level. So that would be a tool for functional segregation that can be orthogonal to network segmentation, for example, and really is on a functional or on an application level segregation. Our OWASP Application Gateway is built to scale from very small projects to very large projects. Naturally, with a new component in the picture within your architecture, there are advantages and disadvantages. Some of the advantages and intentions we already mentioned. For example, additionals are that we come with a lot of out-of-the-box functionality, so there will be less code for you to write on the application services side. We have a reduced complexity for front ends and back ends because the interface, so to say, for authentication is greatly simplified. And we also have a single point of entry into your applications, into your services, which means also a smaller attack surface to the outside, to the public world. I already mentioned that we have an API that basically forms the contract in this area, which helps us also exchanging authentication servers or methods of how we authenticate users. Besides that, OAG comes with a lot of best practices already implemented, such as request tracing, logging, CSRF-prevention, and so on. On the disadvantages side, however, we have the fact that adding a component also usually adds to the complexity of the overall architecture. Besides that, with OAG, you have a single point of entry, which also means there is also a single point of failure. While it would be possible to scale the OAG, that's something you currently would have to do on your own because we are not yet there to provide that out of the box. And besides that, our OAG is configurable, yes, but it is also opinionated in some areas. So it makes sense that you verify that your architecture vision actually is a match for the OWASP Application Gateway. This is just again a short summary of the main features we see that OAG provides. I've mentioned the decoupling of the enterprise single sign-on solution or the authentication server or identity provider. I already mentioned that we do session management with absolute or with rolling session timeout, so we're flexible on that. We also provide downstream authentication based on JSON Web Tokens, including automatic key rotation for the signing key of the JSON Web Tokens. We offer request tracing with compliant to the W3C trace context specification. We offer login with OpenID Connect and GitHub out of the box, and we have added CSRF protection for everything. Some of these features we'll discuss further down the line in a bit more details. But let's first take a closer look at how such a typical flow actually looks like. We have the players listed at the very top of the screen, which is in our case, for this example, the browser. It's our OWASP Application Gateway. It's an identity provider or authentication server, and it's microservices. That's one that stands in place for all of them. The initial part, so the first few calls basically are nothing else than the OpenID Connect code flow. So what bit simplified displayed here. So what happens here is the browser requests basically the first service. It does this by going through the OAG, and OAG detects that that user is not yet authenticated and redirects it to the identity provider, which is then the next call from the browser. So the browser then does the authentication dance together with the identity provider or authentication server. And if the authentication server is happy, it redirects back the browser back to the originally requested page. And this time the request also includes either the access code or the access token provided by the identity provider. What OWASP Application Gateway now does, it validates this token provided by the identity provider, and if it's happy with that, basically the user is authenticated. What now follows is the OWASP Application Gateway magic here. So after validating the user's identity, we actually create a unique session ID for that user, and we create a OAG JSON Web Token. This token we directly pass down together with the original request to our services. Now our services receive a JSON Web Token, and they have to validate this JSON Web Token. That step is still required and a major requirement to make things secure. It makes sure that the identity passed was not changed and is correct. So validating the JSON Web Token is done basically using the standard as described in the standard, and it includes one step. It requires signature proof. So it requires to verify the signature of this token. To get the public signing key part, the service can call an endpoint provided by OAG, the well-known JWKS endpoint, and request the key that was used to sign this JSON web token. Using that key, signature can be verified together with all the other data in the JSON web token, and when everything is valid and fine, we can execute the call and just do our business logic as intended and return the result. So this is the basic flow when a user the first time hits a service. Obviously, subsequent calls are way easier because we already have the session cookie in there from on the browser side, or if you can't use a session cookie, a shared session ID, and we then just need to validate the session ID, send down the previously created JSON web token. The service has to validate again. Usually it doesn't need to request the key again because it's already cached, and execute the call, and this is it. It's worth mentioning that as of speaking, validating the token on this side is something we expect the service to do on their own. So as of today, we do not have a dedicated library that we provide. However, as it's quite simple and, for example, built in already in SpringBoot and similar frameworks, we see no immediate need for that. Yet we have documentation that introduces you to this topic if you're interested. Now, having seen how this all works in theory, let's take a look at how this all works in practice. And for this, I'll hand over to Gian-Luca.
Perfect. Thank you, Paddy, for the introduction. And also hi from my side to everyone. So I'll do a short demo how this looks like when a user uses an application with the OWASP Application Gateway. What you see here is a simple architecture of a demo application that we built with the Application Gateway. This is all hosted currently on Azure, just for demo purposes. And you see we have an instance of the Application Gateway, and this is the only part that the browser speaks with directly. On the right side, we have 3 different services. First one is just a static host for the front end, implemented with a simple Azure Blob Storage. And down below, we have a backend service that serves the main API of the application. And just for demo purposes, we also have a echo service that just displays the request like he gets it, and that allows us easily to see how the request exactly look like when a backend service gets such a request. But before I now want to show you that in action, I want to show you the configuration file of the setup, because the configuration file should be very self-explanatory and give you a good impression how OAG is configured and what actually can be done there. So for that, I need to share my window. Perfect, thanks. Okay, so you should see my window of Visual Studio Code. What you see here is now the full configuration file of this instance of OAG. And as you can see, it's a simple YAML file. So that means it's easy to read by humans and also to write. It's quite easy. There are 2 main parts. First part is here the definition of the routes of the gateway. As you can see, we have here these 3 routes that correspond to one of the service that you have seen on the slide. There's, for example, the static front end, which is served under this public URL. As you can see, there's also a path. This path tells the gateway which requests it should forward to this route definition. For the API, there's also such a path configuration, but now you can see there's a prefix API and a wildcard after that. Because in OAG, the more specific route has more priority. If you call, for example, a endpoint users / API, this will get forwarded to the backend instead of the front end. So that's basically everything, but you also can define some more like if anonymous users should be able to use this backend service at all. If not, OAG can automatically use or automatically log in the users, or also block the request if you wish that. So that's the first part, this definition of gateway route. The second important part is here the login providers. With login providers, we mean in the application gateway different methods how users can log themselves in. We currently have 3 different providers. First one is Google, and for that it's just a simple OpenID Connect login. So here this type tells OAG which implementation of a login provider it should use internally. And here we have the settings that I got from Google when I registered a login with Google. We also have support for GitHub authentication. GitHub is similar to OpenID Connect. It's also based on OAuth 2, but it's a bit different. For example, GitHub doesn't provide you any ID token, and because of that, it's sometimes quite hard to integrate GitHub and other OpenID Connect provider because the way they work is a bit different. But because OAG supports, for example, now GitHub, you can use GitHub in exactly the same way as you can do with other OpenID Connect providers such as Google, or for example, or every other OpenID Connect login, like for example your Office 365 account, or also a private private identity service. For example, we also have an example here with Auth0, which is such a private IDP. Down below, there is some more things that you can configure. Now in this demo, we wrote those very explicitly, but the rest of the configuration file is basically there are default values for everything, but you can override values if we like. For example, here in this area, we define how this shot token, which is sent to the backend, should exactly look like. For example, you can define here the claims that will show up in this token. Well, so let's go to the browser and see that in action. For that, I need to change the window I'm sharing. Let me do that. So I should see now this browser window of this very simple application. So reload this, that it's all fresh. This is a very simple blogging application. So you could write blog posts here, something like Medium, but this is just for demo purposes. The actual content of the application is not so interesting for this demo. As you can see now, currently we're not logged in. So let's do that. For that, I can click here on sign in. And now I see these different options for the different login providers that are configured in OAG. Now I need to mention that This here needs to be implemented in the front end, but those buttons you see now are basically just links. And if you click to this link, you will get logged in by the application gateway. So for example, when I want to log in with Google, I need to redirect the user to this URL, auth, and then the name of the provider, name how it's configured in the configuration file, and now log in. And that tells OAG that the user wants to log in with Google. So let's do that. You see, the OAG started this OpenID Connect login, and we get redirected to a Google domain. Because I'm currently logged in with different Google accounts, I can now select the one I want. Let's pick my OWASP account, and we will get redirected back to the application. So that was everything. Now you can see that, for example, I'm logged in, and also the profile picture is provided to the application. But how does this look like for the backend? To do that, we can use this special echo route I mentioned. So let's go to this echo route. And now you see it's a very simple application, but it reflects the request in a HTML document as it gets it. We can see that there are some headers added by OAG. For example, we have this status header. Currently, the user is authenticated, but the main thing, or the main way that OAG tells the backend who the user is as Paddy described with this JOT token. And this is sent here into authorization bearer header. But of course, if you would, for example, want to change how this header exactly is named, also, then you can then you can change that in the configuration file. So let's take a closer look at this header, or at this token that is here sent to the backend. For that, I have here a simple application that shows what is in this JWT token. As you can see, there are some claims added from OAG. For example, the first one is most important. Sub means who is the user of the application, and this is my unique ID prefixed with the name of the login provider. And you can also see there are a lot of different other claims, like if my email is verified, and also, for example, my profile picture at Google. That way, the application knows how I look like. Because this is created by OAG itself, you can also see some custom claims. For example, here the provider tells you which login provider the user used, in case that's important. For example, if you have different login providers, for example, for external users, but also internal users that may be logged in, for example, with your Office 365 account. Maybe also you spotted that the validity of this token is quite short. You can also define that in the configuration, but currently it's only 30 seconds. That's enough to have it cached, so that OAG doesn't need to generate a new token every time when there are multiple requests. But it also makes it practically impossible to use this token if, for example, it shows up in a log file or so due to the programming error in a backend service. Yeah, that's it. And of course, you can also here see my email and all the other claims that you might configure. Good. That was it already for the first demo. Later, I'll do a second one But I guess for now, back to you, Paddy. I think you're muted still.
Clever. Thanks, Gian-Luca, for this first demo. Let's continue with what we see here, what we saw here. So one nice thing we saw, I believe, is that actually OAG really decouples the application or the backend services from the authentication task. All the authentication was done actually by OWASP, and the applications just had to verify the JSON Web Tokens. But all the complexity of, in this case, the OpenID Connect flow, they are abstracted away and are also easy to be replaced because it's just in one place now where you implemented it in the gateway. By the way, OAG now comes only with OpenID Connect and GitHub integration, but it's also very easy to implement your own implementation. For a customer, for example, we have implemented a Kerberos-based implementation which worked perfectly well. The next interesting thing, also being very close to that, we're using our own JSON Web Tokens. This de facto means that the identity is in our control in a way. We kind of decide on OWASP Application Gateway what identities we trust from the outside world, and we provide that one to our internal services. And the internal services only need to trust our OWASP Application Gateway and nothing else. So this is kind of a trust zone of services we have in there that's built on top of the OAG JSON Web Token, which is a very strong concept compared to what we have in the outside world, where we saw we have a session ID or a session cookie, as well as the authentication server token. But now, when you think that anything from the outside world gets lost or stolen, this secret information cannot be used within your own services here, because here you just trust tokens issued by the gateway. So obviously this means the attack surface is reduced to what's really made available by the OWASP Application Gateway. So direct calls, for example, are no longer possible at all. The next thing we saw was the stateless session management. So as mentioned, OAG stores the session as an encrypted session cookie and on the fly replaces it with a stateless JSON Web Token, which validity period you are free to configure according to your needs. All of this is obviously cached so that we have better performance. And the last thing I want to introduce you to, or the second last thing, is how downstream authentication works in a bit more detail. That the really big thing here is that it's near zero configuration to verify identities in backend services. And this comes to the fact that OAG generates at start time a signing key, a public-private signing key pair, and uses the private key part to sign this JSON Web Tokens, while the public keys are made available in a JWKS endpoint. So there's an endpoint on OAG where you can request signing keys, public signing keys. This is possible because within a JSON Web Token, we have a header called JKU, which contains, for one, the endpoint URL here, and for other, the key ID, so the key used to sign that token, and obviously also the signature. Now on the backend service, you can actually request the public key that's required to verify the signature. Now, why is this even secure, you might now ask? Well, we leverage the TLS, PKI for that, so the SSL certificate basically. This is something that usually most enterprises and most companies anyway have and already have. And for this, we just make sure that we define on the backend service, well, what domains are trusted at all to provide such public keys, and they need an SSL connection so that the host name actually is verified by TLS. And together, this makes it perfectly secure, as a perfectly secure way of zero configuration to get a public signing key to verify signatures. This, by the way, as a JWKS is standardized in an RFC 7517, and therefore also implemented by many or other products such as JBoss, for example, or Spring has an implementation for that, and so on. So they are all able to automatically load such public keys from OAG. And as mentioned, the validation part here is not yet provided explicitly by OAG, but we have documentation on that, and many products already come with an implementation that works out of the box. And maybe the last thing to kind of point out is that we also support W3C based trace context and correlation ID logging. So what this means is that whenever a request enters OAG, we assign a unique trace ID to that request, and we pass this trace ID down to all backend services, and they obviously can also forward them to all the other services they use. If you make sure that this trace ID is part of your log files, like shown here, then you actually have a perfect log correlation, which is a very cool thing, one for security reasons to figure out what happened in the system, but also when you're debugging the whole system. If you're not happy with the W3C trace context, it's quite complex and consists of two HTTP headers, basically, trace parent and trace state. You can also choose to take a very simple implementation that's just a very simple one header solution. Or you can even create your own implementation for log correlation or request tracing. So having said that, I'll pass again to Gian-Luca.
Perfect. So now we've talked a lot about how this works in detail. What I now want to show you or explain is a bit more what's the higher level design principles of the application gateway, because this kind of influences if you think it's a match for your system or not. So the first design principle that we use during development is, in my opinion, most important, and that is that the application gateway is designed in a way that it follows a secure by default kind of way. This means basically two things. First, if we implement the default configuration that comes with the out-of-the-box version, has settings that are chosen according to current best practices when it comes to system security. It also tries a bit to lead you in this kind of zero trust approach within your backend services. The second thing this means is that if we implement or if we design a certain feature, we try to design that feature in a way that it's hard to misuse. This makes programming error, for example, in the backend verification less likely. This sounds easy. It's actually quite hard to design a feature in such a way. And it also means that we don't support certain, maybe less recommended ways to authenticate, for example, out of the box. But if you want to do that, this should, of course, always be possible. And for that, then I guess the second design principle is very important for you. And that is that OAG is implemented in a way that it's very easy to extend with your own code. So you can add, for example, new kind of login providers or methods how to authenticate against a backend URL. So there are predefined like entry points where you can add new functionality, but the gateway itself is based on a Java Spring stack, and everything inside the gateway is configured with Spring Beans. And so if you want to, for example, change something internally, like for example the way how requests get logged also, then you can simply override our configuration beans, and that way you can add your own logic. Or for example, also if you want to add a filter for a request that maybe changes something, that isn't something I would recommend. But if you want to do that, that's basically no problem. You can just add a Spring request filter. The last design principle is that the whole configuration of the gateway is stored in one central configuration file, as I showed you before. This has two main advantages. First of all, it's very easy to directly see what's going on the gateway, because you can simply check directly the configuration file and everything you will find in there. So there's no, for example, login of the gateway itself, where you can, for example, log you in and maybe change the routes of the gateway, as you maybe know it from auto reverse proxies. Yeah, so the only way to change the configuration is this central configuration file. The second advantage of this is that you can add, or you can store this configuration file in a version control software, such as, for example, Git, and then automatically deploy it with a CI/CD pipeline. And in my opinion, that's a really good way to transparently make changes in your infrastructure. So it also kind of allows you to make changes with an infrastructure as code approach. Could you go please to the next slide, buddy? So those are like the principles how we try to design the gateway. Here are two additional kind of design principles or internal decisions that we took how we implemented the gateway. The first is that the gateway has a non-blocking network stack. In a nutshell, this means that there is a event loop and no new thread is created when a request reaches the gateway. This really allows you, or really enables the gateway to compute or to basically route many requests at the same time. And also, for example, if the backend has some delay, because there needs to be some processing. This doesn't really have an influence on the performance of the gateway. It also, for example, enables back pressure. If the network load gets too high, then you could, for example, delay the responses of requests to the front end. That way, all the front ends will automatically make a bit less requests because the loading time is a bit higher. The second internal architecture decision is that the gateway is designed in a mostly stateless way. That is really important, for example, for horizontal scaling, not only for performance, but also for redundancy, because the gateway, as we have seen, is also a single point of failure. So in certain environments, maybe higher availability becomes really important. There is still some need for some interaction between different instances. For example, to exchange session IDs when the user has signed himself out, because that way we can enable a server-side logout, which is kind of not possible with a totally stateless architecture, but maybe for environments or for applications with high security requirements, a must-have feature. So this was about the internal architecture. Could you go please to the next slide, Paddy? Perfect. If you now would want to use the gateway, there are basically two different models. The first model is that you use it with the out-of-the-box version. And I believe that this is the right choice for many systems. Then you get all the default features, and you simply need to write your own configuration file and, for example, mount this to the Docker container if you use the Docker image. But you can also directly use a Java release. The second way is, or the second way to use the gateway is when you want to extend it with your own code. Then it's really helpful that the gateway itself is a Spring application, and there's a public library that you can integrate in your application, and then directly add your own code. So I will now show you quickly how this could look like and what you can do with that. Yeah, that brings me to the second demo. And now I need you to and show you my IntelliJ. Perfect. So show this window. So okay. Now you see an example how you can extend the gateway. The first thing that you need to do is to add, if you use Maven, in your POM file, this dependency here. So you need to create this SpringBoot application, and then you just need to add this dependency here, and then the gateway will automatically be added to your application. The only thing you need also to do is to use this annotation, enable OWASP Application Gateway. If I now run this, we can see how this looks like from the server view. So we can see, for example, now the logs of the gateway, and take some seconds to get started. So now it's started, and it prints, for example, out the different routes. If you want to take a look at that. If we now make a simple request, for example, here with curl, you can see here now in the logs all the logs that belong to this request, And we can also see this trace ID that is generated. This is now with the W3C standard, and this trace ID now shows up in every lock that belongs to that request. Now I want to show you how to extend it, or basically just show you how that could be done. For that, I implemented a stub login that implements a simple mock login. To do that, you can simply create a new, or for that you need to do a new component, and there is a certain convention how you need to name that, so that OAG finds out that this is a new kind of login method that you want to use. For that, we need to here create a factory class for that kind of login driver. And then in this login driver class, you need to implement like where you want to redirect the user and how you process the authentication. So in that case, I don't want to go into the code right now, but here is a simple stub login implementation where the user can choose his own username. To see that in action, let's open a browser window. So you should see now again my browser window, and if I now go to a local instance of the gateway, you see this now serves a different site. But if I log in with my new login provider, this is at auth stub login, I get redirected to this mock login page and can now choose my username. Let's take GianLuca, and my email, which is really cool, Gian-Luca.Frei. Let's log in. And now use again this echo service to see what is going on the backend. And if we copy now this JOT token, we can see again that now my name or my ID is Gian-Luca, and also the email that I'll enter it. Of course, this kind of login method is totally insecure and never something for a real web app, but it just shows you how you can extend it. But even, for example, for a testing environment or so, I can imagine that this is quite useful because then you can just choose the user that you want to do the testing with. Yeah, that's it. Now let's go back to the presentation. Perfect. So maybe a few words about what's the current state of the project. We need to mention that the gateway is still work in progress, but everything that you have seen is implemented and also in a kind of mature way. So this is all production ready, but we still lack this kind of inter-node communication, which is needed if you want to have a environment with multiple instances of the application gateway. Could you go to the last slide, please? Perfect. Yeah, here you can find more information. First of all, we have our GitHub page. There is, of course, the code, but also in the wiki, you find a lot of documentation, how exactly you can configure the gateway, and also tutorials, how to install it, and for example, how to integrate it with a Spring application or other applications. There's also a website on our OWASP website There you can also find some basic information. At that point, I want to tell you we're always looking for feedback. So if you have something to say, something that you maybe think is cool, something you think is maybe a feature that is not so designed in a good way, or maybe a certain thing that you would expect a reverse proxy, such as this gateway to have, then just maybe write us a mail. You can find our emails on the website, or of course also in this slide set. And also, of course, if you want to contribute, then just ping one of us. We of course always are looking for new contributors to the project. Yeah, that's it. Thank you all, and I guess now we have some time for questions.
Yeah, I guess so. If Imo agrees, then I'll immediately start off with what I found in the question sections, or I'll hand back to you first.
Yeah, that's fine. I mean, I've put some questions myself in case we didn't get any from the audience, but there are plenty from the audience, so let's go with those first.
Cool. So we had a first question from Pat, who was asking, with the profile picture, could you do or add an image search to ensure it wasn't being misused? Well, on that one, no, not well. That's not something that comes out of OAG out of the box. If you do want that to happen, then you'll have to do that yourself. What OAG basically does, it takes the information it receives from the authentication provider based on your configuration, it forwards the information you want within the JSON Web Token it itself issues, but it does not do image processing or some such things. What it, however, does, it verifies that the image link, for example, was received from a trusted endpoint. So it really makes sure that the image link was really provided by Google or whomever you use as an authentication provider. But if that party would have been compromised for any reason, then you wouldn't detect an image change or something like that. Hope this answers your questions, else just feel free to kind of re-ask on that one, and make me aware of what you really meant with that. Then we have another question also coming from Pat again, asking whether OAG can actually handle wildcard certificates. And yes, it can handle that one. That's no problem. You can issue a wildcard certificate for OAG itself. Then you obviously must make sure that you also accept the wildcard certificate on the client side when requesting the keys. In that case, it would be really important to make also sure that the OAG actually runs on a trusted domain, meaning has a host name that you trust for key issuing. Else, I guess that it would be too widespread of an option for an attacker to use other hosts too. Having said that, I see we have another question, whether we can share the Git link for that one. I think we can do that, no problem. You have it right now, I guess, on the screen, but I might be able to copy that to, oh, bad luck. We might be able to copy that into the chat and provide you as that as a side note within the chat. Maybe Gian-Luca can do that in the meanwhile. Thanks a lot.
Yes, make sure you send the answer to all. Thank you.
And then I think we had other questions. One, and I believe that one is quite important, is does OAG actually handle procedures such as forgotten password or password change or whatever? And the answer here is no, it doesn't, and it's not OAG's job. OAG is the middleman, so to say, in between your applications and the authentication server. And it's only the authentication server that has the authority to actually handle such cases because it's the owner of the identities. OAG isn't the owner, so it can't actually handle these cases. Obviously, if you also own the identity provider, you could come up with a solution that kind of integrates the two in one way or the other, but that would be custom development on your side anyway. So short, no different responsibilities, OAG to verify the identities and authentication server identity provider to own and manage all the identities, including flows such as forgotten passwords. Then we had a question on how difficult it would be to include Azure AD as an identity provider or authentication backend. That's maybe something you can answer quite quickly, Gian-Luca, right?
Yeah, sure. So Azure AD actually offers you that it provides a OpenID Connect way to sign you or to integrate your applications. And that means that this is very easy. You can do it exactly the same way that I showed you with the signing with Google. You just need to get the values of the authorization endpoint and, for example, client ID and client secret in your Azure portal, and then you need to add those to the configuration file, and for that you basically need zero code or so.
Thanks a lot, Gian-Luca, for that one. And then we had one that I personally felt is a quite tricky one, as we're still a very young project. How do you size the virtual machine on which you run OAG? So how big must the machine be that OAG runs fine? My experience from my one customer project is it was just good enough, the standard VM they had by far. So we didn't need anything near the upper bounds of what they provided. But do you have, and we also did some measurements based on open OAG now, and based on OAG used another approach to kind of act as a proxy, so with another framework below, and now we're kind of factor, I don't know, I can't remember, 100 times faster, or what was it, Gian-Luca?
Yeah, I can tell something about that. So the processing speed hardly depends on how the requests exactly look like the size and the delay from backends and how much in parallel and so on. But I measured it with my local MacBook Pro, which is not first generation, but also not latest, something in between. And there with a very simple setup, I managed to do around 6,000 requests in parallel, where the backends have a delay of 2 seconds. So I guess for the performance, because the networking is based on Spring Webflux, this is not really a big issue. And if you want to have a scalable version of your OAG instance, then because it's a simple Docker image, it's very easy to, for example, use Kubernetes for that, for automatical scaling. And also, of course, for example, the Azure App Service that I used also would kind of offer this automatic scaling. So you can, yeah, it really depends on the load that you have.
Thanks a lot. So I believe we're quite through with questions, or did I miss something, Imo?
I think not. The only one is some people are requesting copies of the slides. Is that possible? Do you want to give me a PDF or something like that? Then we can post them to the BCS SPA website.
Absolutely, yeah, no problem.
Fantastic.
With pleasure, actually.
Okay, well, I'm really grateful. It's been a very interesting technical presentation, and yeah, I've learned a few things about SpringBoot and so on as well along the way. So thank you for that. I hope that our audience has enjoyed the talk. The recording should be appearing on our YouTube channel before very long, and the BCS SPA website has a reference to that. So you should be able to find it before the end of the week. Just a reminder, we've got another meeting in a month's time. This one's on software quality, software defects, and the law, of interest to all software practitioners, I think. And in between those two is the annual BCS SPA conference. This year is quite different to the usual framework, but we're trying to capture as much of the spirit of the usual conference as we can. We've spread it out into 8 sessions. There's a morning and an evening session on the Tuesday, Wednesday, and Thursday. There's an afternoon session only on the Monday and a morning session only on the final Friday. So all of that runs from the 13th until the 17th of September, so quite soon. Signing up is quite low price. It's only £130 for the whole thing. There are 2 tracks, lots of interesting interactive workshops, and you can come for as much or as little as you want. There are discounts available for students at other concessions. So please have a look at spaconference.org and sign yourself up. I think we'll leave it there. Thank you very much again for coming. Thank you to our 2 fantastic presenters. You may have noticed, Patrick and Gian-Luca, that you can choose one of the BCS titles as a book to be sent to you. I don't remember seeing that you made a choice. Do have a look. It's on bcs.org/books. And if you'll let, you've already been corresponding with Mandy Bauer about setting up this talk. So if you'd let her know which titles you'd like and where you'd like them sent, then she'll arrange that.
Cool. Thanks a lot.
Cool. Yeah.
It was a pleasure being here. Thanks.
Excellent. So I'll stop the recording now, and we'll see everybody at the next occasion. Bye.